Okay, so you guys can hear my voice and see my screen, right? Right. Hello. So you guys have an exam this upcoming Friday, correct? So I can either concentrate on doing worksheet 7 and then come back to spend whatever extra time I have on the exam review, or I can do a quick sampling of the exam review and then switch over to worksheet 7 to cover as much of that as possible. Which would people prefer I do? Euler. Okay, cool. So I'll start off. I do want to cover as much of worksheet 7 as I can, so I'll probably just do a quick sampling of the exam review rather than go through the whole thing. Oh, oopsies. This is not what I want. So this is, if any of you guys want if you want to know where you can find the answers for this, you can just Google Drexel Math 102 Winter 2021, and then go to the answer key. But we'll be working on the review problems. So I'm going to do A and D. B and C should be in the video that I'll post for my recitation from yesterday, but they're the same basic ideas. This is just chain rule within quotient rule within chain rule, and then this guy right here is just chain rule. So I get 6 times 8 from this guy times the derivative of the inside, that's 2x, times x squared plus 4 to the 7 by the chain rule and power rules. Then this guy right here is going to be the chain rule for the top, the chain rule for the bottom, and then a quotient rule between them. So the quotient rule, again, is bottom times derivative of the top minus top times derivative of the bottom all over bottom squared. So this guy right here, the derivative of the top is going to be equal to 16 times 8 times x to the 7. And then we have times 1/4, and then times 16 x to the 8 minus 81 to the negative 3/4. And then derivative of the bottom is going to be equal to 15 times x minus 5 to the 14. So that all ties together to give us bottom times derivative of the top. So that's x minus 5 to the 15 times derivative of the top is this guy. I'm just going to put that as t prime to save time on rewriting, but I'll trust you guys to figure that out. Minus the the top times the derivative of the bottom, so that's 15, x minus 5 to the 14, and that's all over the bottom squared, so that's x minus 15 to the 30. Cool. Do people want me to do B or C in particular? If not, I'm just going to jump on to the next problem. Cool. So find the derivative of each of the following functions. I will do A here. So there's a couple different ways you can do this. You can try to factor it and then split it using laws of logarithms, but the easiest way to do this one's just going to be chain rule. So the derivative of the inside and then the derivative of the outside with respect to the inside. So that will give us f prime of x is going to be equal to 4 times 10 times x cubed minus 7 x squared times 3 plus 5. That is times, not a minus. And that's all over 10x to the fourth minus 7x cubed plus 5x. So then we can do this guy. If we do g prime of x, that's again just chain rule, so derivative of the top times that guy. So the g of h of x is going to go to h prime of x e to the h of x. So that's the general rule that we have for, that's how the chain rule manifests with e to the function. And in this particular case, that'll become 5x to the fourth minus 36x squared. That times e to the x to the 5 minus 12x cubed plus 8. So that guy right there is A and B, and then I will do G and jump on to the next section. So G here, E here, G prime of x is going to be equal to 4 times 51 from this guy, and then I have to do the derivative of the inside, so it's e to the x plus 8 over x plus 2 times 1/4 x to the negative 3/4. And then this whole thing is still times e to the x plus 8 ln of x plus 2 times the fourth root of x to the 50. So these guys, by far the easiest way to do them when we have these big exponents is the chain rule. In theory, if you wanted to, you could like multiply it all out and get something that is equivalent to this, but don't do that. Do people have any questions on 2 before I move on to the next section? Cool. So a model for the number of people in a college community of 1,000 students who have heard a certain rumor is given by n of t is equal to 1,000 times 1 minus e to the negative 0.15 t, where t is the number of days that have elapsed since the rumor began. So how many students have heard the rumor after 2 days? So this is, you literally just plug in t, or 2 for t, so then we get, this is asking, this right here is just saying, hey, what is n of 2? And that's going to be equal to 1,000 times 1 minus e to the negative 0.3. And you can plug that into the calculator to find what that is approximately equal to. So find and interpret the rate at which the number of students find and interpret the rate at which the number of students who have heard the rumor is changing after 2 days. So that's just basically asking, hey, what's the derivative at 2? So to do that, we're going to first do the derivative with respect to t. So it's going to be equal to 1,000, and then we'll get so 1,000 e to the, so first I'm just going to distribute this. So this is 1,000 minus 1,000 e to the negative 0.15t, right? So when I do the derivative, this guy goes away, and then I'm just left with, I'm dealing with this guy. So I have negative 1,000 times negative 0.15 times e to the negative 1.5t. So when I do the derivative with at 2, then I get this becomes what? That becomes positive, and then get rid of those, move this decimal over, we get 150 times e to the negative 0.3. And that is going to be our answer for B. That is the rate at which the students are hearing this rumor. That is the number of students per day who are hearing this rumor after 2 days. That is the instantaneous rate at which they are hearing it. So use the results from A and B to estimate the number of students who will have heard the rumor after 3 days. Compare that to the actual result of 362 students. So this would just be equal to, so this is just saying that n of 3 is going to be approximately equal to n of 2 time, or plus n prime of 2 times 3 minus 2. So this is saying one of our other points plus the slope times the change. And if I do that, the answer, the value that I will get is going to be equal. This guy right here is going to be roughly 259, and this guy right here is roughly 111. So we end up getting a little bit more than what we would have wanted, but not much more. This ends up being what, 370. It's a pretty good estimate, and probably the farther away you go, the worse the estimate will be. But it's a good local estimate. It's a good local linear approximation is the term. But if you were to use this to estimate it after 40 days, probably not that good of a guess. It's a good local estimate. So find the equation of the tangent line to the graph of f of x is equal to 11 minus x plus 4. Okay, so this guy right here, so I need two things, right? I need two pieces of information. I need the point and I need the slope. To find the slope, to find the second value for the point, because I need the y value, I just plug in 1 here. So I get 11 minus 1 plus 4 times 2 times 1 minus 1. And this is, ln of that. So ln of 1 is just 0. This whole thing goes away to 0. And I'm left with 10. So I get the point 1 comma 10. And then this is going to be the point that I use. Now I just have to find the slope. So I need to find the slope of the tangent line. That's just the derivative. So I do f prime of x is going to be equal to negative 1 from this guy plus 4 times 2 from this guy divided by 2x minus 1. But if I plug in 2x minus 1, if I plug in 1 for this guy, right, I do f prime of 1, and I get negative 1 plus 4 times 2 divided by 1 is equal to 7. So I have y minus y naught, so 10 is equal to m, is equal to m times x minus x naught. So that's 1. And then if you want, you can rearrange this into y equals mx plus b form. But if you do that, then you'll get y is equal to 7x plus 3. If you just distribute the 7 and then move this guy to that side, the 10 to the other side. Does that make sense to people? Cool. So for each function below, find the x-coordinates of the critical points, determine the intervals on which f of x is increasing and decreasing. Find the x-coordinates of any points of relative extrema. So this is what we did last week, right? So the points of relative extrema are only going to be able to occur when the derivative is equal to 0. So the first thing I'm going to do for each of these guys is set the derivative equal to 0. Actually, I'm also going to check that this is defined everywhere, but the first 3 are going to be defined everywhere, and the fourth is just going to be defined at x equals 1. So the derivative of this guy is going to be equal to 4 minus 20. So that gives me 12x squared plus 14x minus 20. And now I want to set this guy equal to 0 and then see how I can factor this. So first thing I'm going to want to do is I can pull out a 2 from everything, just make this a little bit easier to look at. So I get 6x squared plus 7x minus 20 is equal to 0. And I can mess around with this, but this is a quadratic equation. This is a quadratic function, right? Minus 10. Yes, thank you. That should be minus 10. Thank you, Kat. So this, I could factor this and say, okay, it's either 6x and x and paired up with something, and then it's also either, or it's 2x and 3x paired up with something. Instead, I'm just going to use the quadratic equation and say x is equal to negative b, so that's negative 7 plus or minus the square root of b squared, so that's 7 squared minus 4ac, so all over 2a. So this guy right here is going to be equal to negative 7 plus or minus the square root of 49 plus 240 all over 12. And I guess that does not have a nice clean answer, does it? 249, 49. Okay, yeah, so this is just going to give you 2 points, and then you'll, this will be plus or minus, and then you'll check it along either of those intervals. It's going to be the same exact process as I'll do for the next couple, but I want to save time, and this will take a while checking everything. So I'm just going to skip along to the next question. But it's going to be the same exact procedure. In fact, it'll actually be slightly easier because there'll only be 2 points instead of 4 potential ones that you have to check. So let's do the derivative of this guy, and that's going to give me 5x to the 4th minus 20x cubed minus 60x squared is equal to 0. So now this guy, I'm just going to see how can I factor this. I can pull out a 5, right? And I can pull out an x squared. And that leaves me with x squared minus 4x minus 12 is equal to 0. So then I say, okay, how can I factor this guy? And that is going to be equal to x plus 2 and minus x minus 6. So I now have 3 different points that are going to be potential, or are going to equal 0. And this guy is actually a good one because this is, at this point, I get a double 0, and that's going to be a point of interest. It's going to act a little bit differently from what we're used to, basically. So I need to check. This guy gives me x is equal to -2. This guy gives me x is equal to 6, and these two guys both give me x equals 0. So that tells me that my intervals are -infinity to -2, -2 to 0, and 0 to 6, and then 6 to infinity. So let's plug in values into this. So if I plug in, let's say -10 as a test value, then I would be dealing with 50,000 here, minus 2,000, or sorry, 20,000, right? Minus 6,000. So this right here is going to be positive. Then what about from -2 to 0? -1 seems to be the best test point. This test point was at -10. So if I plug in -1 as a test point, then I would get 5 times 1. -1 to the 4th is positive 1. Minus 20 times -1 cubed. So that's positive. And then minus 60 times -1 squared. So this is 5 plus 20 minus 60 is negative. If I plug in 1, I will get almost the same thing, but it's actually just it's going to be 5 minus 20 minus 60. So that's actually a bigger negative. And so that's what I was saying in terms of it's unusual to have 2 consecutive intervals. That's not what you're normally used to seeing that have the same sign. But it does happen. The kind of go-to example of this is x cubed. That's everywhere increasing, even though the derivative is equal to 0 at 0. And then here, if we plug in, say, 10, oh, sorry, this is actually 10 that I plugged in up here, but if I plug in -10, this would end up becoming positive if this is -10. Either way, it's positive. So it is increasing on the intervals -infinity to -2 union 6 to infinity, and then it's going to be decreasing seeing on -2 to 0 union 0 to 6. So technically it's still not decreasing at 0, so you shouldn't just do -2 to 6. Then you should also check these 3 points to tell me, hey, this is a relative extrema, and turns out 0 is not a relative extrema, right? Because it keeps on decreasing on either end of 0, but you're going to get a local max at -2 f of -2, 2, and at 6 comma f of 6. Does that make sense to everybody? Okay, I'm going to do one more question, and then I'm going to switch over to the worksheet 7. So that's a pretty long worksheet, and we're not going to get through all of it as is. Do people have one of these that they actually want me to do? Okay, then I'm just going to do 8 because that looks quick. Okay, so instantaneous rate of change is literally just the derivative, so all it's asking me to do is find the derivative. X ln of x, so f prime of x. This is just a product rule, so it's first times the derivative of the second, so that's x times 1 over x plus the second times the derivative of the first, so that's ln of x times 1. So simple product rule here, and now I'm just going to plug in, so first off, this guy cancels to 1, right? And I'm just left with 1 plus ln of x. Now I can just plug in x equals 3, and I would get e to 3, f prime of e to 3 is going to equal 1 plus ln of e cubed is equal to 1 plus 3 is equal to 4. Cool? People have no other specific requests that they want me to do. This one was in your last homework, so in the last worksheet, word for word, so. Okay. And like I said, you can also find the answer key on the website. So find the fourth derivative of this guy. So these guys are all going to get wiped out because the power is less than 4. So if your power is the power of a polynomial or a part of a polynomial is less than the derivative, it's just going to disappear, because at some point you're going to go to the constant, and then the derivative of the constant is going to be 0. You guys should be able to check that for yourselves. But so if I were just to, like, the third derivative of x squared is going to make it disappear, because it would go 4x squared to 8x to 8 to 0. So on the third derivative, it disappears. It disappears on the fourth derivative for x cubed, on the second derivative for just regular old x. So then this guy is just going to be equal to negative 2x to the fourth. And then it's going to be basically the factorial, 4 factorial, but because each time you do 4 times 3 times 2 times 1. But we get negative 2 times 4 times x cubed times negative 2 times 4 times 3 times x squared. And then we get negative 2 times 4 times 3 times 2 times x. And that becomes negative 2 times 4 times 3 times 2 times x. I guess there's an invisible 1 there if you prefer that. And that is equal to negative 48x. Okay, so concavity tells me, hey, it's switching from the derivative is increasing to the derivative is decreasing. Not the slope is increasing to the slope is decreasing. That's saying that the derivative is positive or negative. I'm saying that the slope is changing, that the slope is increasing or decreasing. So this point right here is the point at which it switches from, hey, we're decreasing here, but up until this point we're decreasing faster and faster. After this point we're suddenly decreasing slower and slower, until suddenly we're not even decreasing anymore and we're actually increasing. So that tells me that this is concave upwards, or I have a positive second derivative. The single derivative is increasing, first derivative is increasing between negative 2 and 4 concave up. And then I have inflection points. So those are points where it switches from being concave down to concave up, or vice versa, at -2, 4, and at 6, -1. Then I have concave down from -infinity to -2 union 6 to infinity. Right? Because hey, I'm increasing, but I'm increasing slower and slower and slower and slower until suddenly I'm not even increasing anymore. I'm decreasing, and now I'm decreasing. And then over here, I'm increasing, but I'm increasing slower and slower until suddenly I'm decreasing. It looks like I'm going to be decreasing forever and ever. Does that make sense? Cool. Let's do C, I guess. So C here we have this kind of boomerang shape, and it's decreasing, it's decreasing, it's decreasing, then it's increasing, right? But it's the whole time it's decreasing at a slower and slower rate. So that tells me, hey, this is actually concave up over here. So it's concave up from -infinity to 0, and then it's going to be concave down from in the opposite direction. So we're increasing, but we're increasing slower and slower, and then we're actually decreasing. So it's concave down from 0 to infinity. And then there are no points of inflection because the point where it changes, it's just not defined at x = 0. Does that make sense, everyone? Okay, so these two, it's just it's the same basic idea, but now I can actually algebraically solve for the second derivative, right? So the second derivative of this guy is just going to be equal to what I get, -6x minus 12. So I want to find the potential points of inflection. I just set this equal to 0. So this is f double prime of x. I want to set that guy equal to 0 to see where it's going to potentially switch. And the only point that I get for this is going to be, so I can rearrange this to -6, x is equal to 12, and I get x is equal to -2. So x equals -2 is the only inflection point. And now I can it's the only potential inflection point. And now I just need to test on either side to see, is it concave up or concave down from -infinity to -2 and -2 to infinity. So what test points do people think I should use? What is kind of the standard go-to test point if it's possible? Yeah, thank you, Parker. So I'm going to plug in 0 for this guy, and that tells me that I get, if I plug in 0, I get -12. So that tells me that this range is concave down, it's negative. And this guy, I'll plug in, say, -5. In that case, I get -6 times -5 minus 12 is equal to 18. That's positive. So this is concave up. So concave up, -infinity to -2, and concave down, -2 to infinity. Does that make sense to everybody? It's going to be the same thing for E, but you'll get 2 potential inflection points. So yeah, this is inflection point at -2 f of -2. And then it'll be the same basic idea for E, but you'll get 2 different points that you'll have to check, and you'll have to do an extra interval that you have to check, but it's the same basic idea. So apply the second derivative test to find the relative extrema. So first thing I'm going to do is find critical points using the first derivative, right? So I'm going to do the first derivative on this guy. And actually, I'm going to do, yeah, I'll do both actually. So I'll do the critical points on this. So f prime of x is going to be equal to 6x squared minus 8x. And I have to set that guy equal to 0. So if I pull this out, then I get x times 6x minus 8 is equal to 0. And that's going to be x is equal to 4 over 3, or x is equal to 0. And so that's going to define my two potential critical points. I want to find the relative extrema, or whether they're local max, local min, whatever. And I'm going to plug in the second derivative. So if I do the second derivative, this guy becomes f double prime of x is now going to be equal to 12x minus 8. I'm going to plug in these 2 points. So if I do f double prime of 0, I get that's equal to -8. So if it's -8, then that tells me it's concave down where at x equals 0. And kind of contrary to the instinct, same thing as before, the pictures before, if it's concave down, it switches from increasing to decreasing, so it's actually a relative max. So at 0, f of 0, we get relative max. And then if I plug in the 4/3, then I'll get f double prime of 4/3. That's going to be equal to 16 minus 8, and that's going to be equal to +8. So that's going to be the opposite of, it's going to be a relative min because it's switching from decreasing to increasing. And we get 4/3 of 4/3 as a relative max, a relative min. Does this make sense to everybody?
Yep.
Cool. So the same basic idea here. The first derivative, f of x is going to be equal to 4 times x plus 3 now cubed. And now I have to see, okay, what is this? This is going to be so that tells me that x is equal to -3 is my only point. That happens 3 times over. And then if I plug in or if I do the second derivative, I get that that is going to be equal to the triple derivative, right, of this guy is, sorry, the second derivative is going to be equal to 12 times x plus 3 all squared, right? So what am I going to do in terms of plugging this in? I now do f double prime of -3, but that's going to be equal to 0, right? So what happens when it's equal to 0? Test basically fails when it's equal to 0. We don't know what's going on. It could be, so it turns out this is going to be a relative min, and if you just picture what's going on here, it's going to be pretty easy to see. This is basically like a steep parabola, and x to the 4th is kind of a go-to example of how the second derivative test, if it spits out 0, you don't know what's happening because it could be this is a local min, relative min, which is what you get. Or it could also, if you add negative x to the 4, that could be that it's a local max. And then if you have x cubed, that could be that it is a local, or that it's neither local max nor min. It looks basically like this. But if you look at the graph, it'll be pretty easy to see what's going on here. You can also just pick test points in either direction. But the second derivative test fails. Does this make sense to people? Cool. So find the velocity after 5 seconds. So this is the distance function. So the velocity function is going to be equal to the derivative of this. So if I do s prime of t, that's going to be equal to negative 32t. If I do the second derivative of that, it's going to be equal to negative 32. But the velocity after 5 seconds, when I plug in s prime of 5, that's going to be equal to negative 160. And then if I do s double prime of 5, that's equal to negative 32. So the double derivative is not time dependent. Gravity due to acceleration is not time dependent, or we can ignore any minuscule time dependence. Does that make sense to everyone? Good. So find the absolute max and min of these functions. So there's really only 3 contenders on this first guy. It can be x1, it can be x2, or it can be x3. So let's just check x1, or let's work backwards. x3, that's definitely a local min, but it's not going to be an absolute min because x1 is lower. And it turns out x1 is going to be my absolute min. So absolute min x1 f of x1. And then there's no absolute max because, hey, this is a local max, but this point's higher, and this point's higher, and this point's higher. And then, but these guys are also not the maxes because it keeps on going up in both directions. This one, when we're on a closed interval, though, we're actually guaranteed that there will be a max and a min. So continuous function at closed intervals will guarantee that. So we have to check these 4 potential points, the 2 endpoints, and then the 2 relative maxes and mins. And it looks, just by looking at the picture, x1 and x2 are going to be our maxes, or our absolute maxes and mins respectively, and x3 and x1, although local maxes and mins are not at my absolute max and min because obviously these points are higher and lower respectively. Does that make sense? Cool. So I will do one of these problems and then I'll probably try to jump onto 8 just to do one of the word problems before time runs out. So I'll do D. Let's find the double derivative of, or let's find the derivative of this guy. So f prime of x is going to be equal to 6x squared minus 6x minus 12. And now I'm just going to pull out the 6 from that. So that's 6 times x squared minus 1 minus 1x minus 2. And that's going to be equal to 6 times x minus 2 times x plus 1. So that tells me that this is going to be equal to 0 when x is equal to 2 and when x is equal to negative 1. So that actually ends up being just the 2 endpoints in this region. If you were to do this guy, you get another point, which is a point within the region. But generally speaking, you have to test any critical points that are within your bounds and your two endpoints. So in this case, my critical points within my bounds happen to be my two endpoints, and I'll just plug them in. So if I do, sorry, f of 2 is going to be equal to, so that's 16 plus 12 minus 24. So that's going to be equal to 4. And then f of -1 is going to be equal to -2 plus 3 minus 12. So that's equal to -13. So that tells me that we get the min at 1f of 1. So that's the absolute min, and the max at f of 2f of 2. If there were a third point in this interval that was like a distinct critical point, then you would you just plug it in, all of those points into your f value, and then whatever is the highest f value is going to be your critical point, is going to be your absolute max in your bound, and then whatever your lowest one is your lowest, is going to be your absolute min within your bounds. And that's because we're on a closed interval. We're not guaranteed that there will be an absolute max or min if we have an open interval, but on a closed interval, we are guaranteed that we will have an absolute max and an absolute min for a continuous function. So do people want me to do 6 or 8? So I'll do 6. So the total profit P of X in thousands of dollars from the sale of X 100,000 automobile tires is approximated by P of X is equal to -x cubed plus 9x squared plus 120x minus 400 for x greater than or equal to 5. Find the number of hundreds of thousands of tires that must be sold to maximize profit. Find the maximum profit. So this is the function here is going to be P. So the derivative of this is just going to be -3x squared plus 18x plus 120, right? And now if I pull a -3 out of this, I get that's equal to -3 times x squared plus 6x plus 40, right? So what can I do to get, oh, sorry, these guys are both minuses. This is minus, and this is minus. So that factors into x minus 10 and x plus 4. So that's x is equal to 10 and x is equal to -4. But guess what? I can't sell -400,000 tires. This is not in my valid domain, and in fact, it's not where I decided that my function is modeled by. So it's where my function is good for modeling. So it's just at x equals 10 is my possible. So that's when I sell 1 million tires, and if I plug that in to the profit, that is the only point that it could possibly be a max or min. But it's going to be a max, and if I do that, oh, sorry, I also actually have to plug in my point of 5. So I strictly speaking should do P of 5 and then P of 10, because this is my critical point in the bounds, and that is my end point of the bounds. So if I were to do that, then I would get -125 plus 9 times 45 is 225 plus that's 600 minus 400. And that is so this is 200. This is going to give you 300. And then this one right here, that would give me negative 1,000 plus 900 plus 1,200 minus 400. So that would be equal to 21, that's 500. So that tells me that the maximum profit occurs when I sell 100,000. So that's 1,000,000 tires. And at that point, I get $500,000 is my profit. Does that make sense to everybody? Cool. You guys are free. Good luck on your exam on Friday. I'll stick around for a couple questions if anyone has them, but doesn't seem like you do.
Thank you.
Have a good one.
Thanks.